Hi, I'm Alex Barlow, leading expert on polymerization, and today we're going to be talking about PET. So in order to make PET, a process called polymerization needs to be performed. Polymerization is the process of reacting monomer molecules together in a chemical reaction to form a polymer chain. The monomer molecules in polymerization of PET are ethylene glycol and either terephthalic acid or dimethyl terephthalate, also known as DMT. Ethylene glycol is an organic compound obtained from reacting ethylene with water. It is a colorless liquid. Terephthalic acid is also an organic compound. It is a crystalline solid obtained from xylene. It is produced by the oxidation of p-xylene by oxygen in air. DMT is another organic compound which is a white solid. It actually requires terephthalic acid in order to be produced. It is made by reacting the acid and a methanol. There are two ways to make PET. In the dimethyl terephthalate process, DMT and excess ethylene glycol are reacted at 150 to 200 degrees Celsius with a basic catalyst, eliminating methanol. Then, excess ethylene glycol is distilled off at 270 to 280 degrees Celsius in a vacuum, and finally, all that is left is PET. This reaction occurs many times, creating a long polymer chain. In the terephthalic acid process, terephthalic acid reacts with ethylene glycol in a process called esterification. Esterification is a reaction of an alcohol, ethylene glycol, and an acid, terephthalic acid, to form an ester and a water. In this process, it produces PET and water. This reaction occurs at a moderate pressure of 2.7 to 5.5 bar and a high temperature of 220 to 260 degrees Celsius. Just like in the DMT process, the reaction happens many times, creating a long polymer chain. The spaghetti
Scusi, Barbara Boopy? Che cosa?
Peter, what are you doing?
Speaking Italian.
The spaghetti-like strands of PET are then cooled and cut into small pellets.
First, an automated mixture combines PET resin pellets with recycled plastic that has been reduced to flakes. Plastic loses some of its physical properties when repeatedly heated, so manufacturers must limit the amount of regrind they use, typically capping this ingredient at 10% of the total mix. The mix travels into an extruder that then melts the PET at temperatures of about 500 degrees Fahrenheit. A screw inside the extruder compresses the PET mix and injects the nearly molten material into molds. The mold produces a bottle preform, which is sometimes called a parison. The preform looks like a thick-walled test tube, often including the bottle screw top. The preform cools almost instantly as it travels into a machine called a blow molder. The preform then enters a two-part mold that closes around it. The inside of this mold is shaped exactly like the finished bottle. A long needle pushes up through the preform, which is suspended with the screw end facing upwards. The needle stretches the preform towards the bottom of the mold and simultaneously blasts enough pressurized air into the preform to force it against the sides of the mold. This stretch blow molding process must happen quickly to maintain the bottle's integrity and consistent shape. Plastics have become the ubiquitous workhorse material of the modern economy, combining unrivaled functional properties with low cost. Today, imagining a world without plastics is nearly impossible. Plastics are increasingly used across the economy, serving as a key enabler for sectors as diverse as packaging, construction, transportation, healthcare, and electronics. Plastics now make up roughly 15% of a car by weight, and about 50% of the Boeing Dreamliner. While delivering many benefits, the current plastics economy has its drawbacks that are becoming more apparent by the day. After a first short-use cycle, 95% of plastic packaging material value, or $80 to $120 billion annually, is lost to the economy. A staggering 32% of plastic packaging material escapes collection systems, generating significant economic costs by reducing the productivity of vital natural systems such as the ocean and clogging up urban infrastructure. The cost of such after-use externalities for plastic packaging, plus the costs associated with the greenhouse gas emissions from its production, it is conservatively estimated at $40 billion annually, exceeding the plastic packaging industry's profit pool. Since 1964, plastics production has increased 20-fold, reaching 311 million tons in 2014, the equivalent of more than 900 Empire State Buildings. Plastics production is expected to double again in 20 years and almost quadruple by 2050. When these plastic water bottles are discarded, there are 3 different ways it can continue its journey. Bottle 1, like hundreds of millions of tons of other plastic products, ends up in a landfill. As rainwater flows through this massive pile of compressed plastic, the water absorbs the water-soluble compounds, and some of those are highly toxic. When water percolates through any permeable material, these toxins can move into the groundwater, soil, and streams, and other ecosystems, infecting the plants and wildlife. It could take bottle 1 up to 100 years just to decompose. Bottle 2's journey starts on stream. The bottle continues along a stream path, eventually flowing into a river, which eventually reaches the ocean. After months lost at sea, ocean currents pulls the bottle to a massive pile of trash in the ocean known as the Great Pacific Garbage Patch. Here, the ocean currents have trapped millions of pieces of plastic debris, and this is only 1 out of 5 plastic-filled paths in the world's seas. Some animals like seabirds get entangled in the mess, and they and many others mistake these brightly colored plastics for food. This plastic makes them feel full when really they're not. And this causes them to starve to death. These plastic toxins are then passed up the food chain from one animal to another and another, until finally these same toxins end up on our dinner plate. Most plastics do not biodegrade, which means they are destined to break down to small, miniature pieces known as microplastics, which will remain at sea forever. Bottle 3 has the opportunity to live a happier life, and this journey is known as recycling. A truck brings the plastic to a plant to be sorted and squeezed flat and compressed into a block. The blocks are then shredded into tiny flakes, which are then washed and melted and become the raw materials used to make more plastic. And these recycled plastics are reborn and given a new life to be used to make many of the things that you use every single day. And they also help conserve an additional 80% of energy that is typically used when making new plastic water bottles.
There are alternative plastics to PET. A big one is the eco-friendly alternative of bioplastics. Bioplastics are extremely similar in physical characteristics to regular plastics. They can be used to make plastic water bottles and can biodegrade much more readily than the common fossil fuel derived plastic like PET. These bioplastics are derived from sugars such as starch, cellulose, or even glucose, whereas traditional plastics are derived from fossil fuels. A common way to make them is to use sugar canes. Not only does the product do less damage to the environment, but the process does as well. The only problem? It costs more.